Happy Wednesday. Today is the 1st of May. My goodness, how is it already May in the year 2024? So, super interesting. We've had the uh, release, or at least the press release, of the Gemini medical based model. So, remember that Gemini is Google's proprietary model, and unlike a lot of other models out of the box, Gemini is multimodal, just at baseline. So this means it can handle then more than just one type of data. So it's not just text in, text out, like a lot of models, or image in, image out. It's able to handle a large swath. And most interestingly, and why I wanted to put this out today, is it is able to actually take in video and be able to analyze that, which is definitely very not a common capability of most models. And of course, right, this being from Google, and we have a slew of authors that are on here. Just came out on Arxiv on 29 April, and it's very long, something around like 50 something pages. So we're not going to go through all that because nobody wants that. But the goal here is to just at a very high level go over the major takeaways. And really, there are three. I mean, and at least I would submit there are three for consideration. So, one is the fact that it speaks about quality data sets in a consolidated fashion with this paper, highlighting not just ones that are more communicated about within the medical community of Med QA, which is a USMLE benchmark, but also talking about multimodal data sets that are aligned with instructional videos as well as uh, actual diagnostics. So let's see that. And the interesting thing with that, of course, right, is the fact that because we're looking at a multimodal model and not just a text-based model, is it's going to be able to take in information that's much more generally accessible than just, say, taking a text-based data set. And so, yes, highlighting this because, of course, right, it is a regular benchmark, but then also looking at the New England Journal of Medicine and Clinico-Pathological Conferences data set comprising of complex diagnostic case challenges, and then gene Turing. And so some folks, again, they're getting very, everyone's looking at the MedQA, and it makes sense because, again, right, we have the Open Medical LLM leaderboard, which are all just singular data points. But it's much, much more than that. And even the model itself in their benchmarks, they look at much more than just that particular data set. Even here, right, and most folks aren't really looking to this level, but seeing here of both the MedQA and then the New England Journal of Medicine CPC, and then the gene Turing data set. And so going through all that and comparing it, and this Amy model, this is a earlier also Google model that was used and found to be or trained with self-play, much like AlphaGo, and found to be very good at being able to answer clinical questions. And right, so with that, we're really seeing the second point of this and the value, in my N of one opinion, of the fact that we are seeing the reinforcement of the value of this self-play training, where an initially, we'll just say, weaker model or base model can be trained and really train itself in this iterative cycle to improve with human expertise. That sounds so weird to say human, but with clinicians in the loop and really champions in the loop, because it's clinicians who are seeing with an understanding of this isn't magic, this is math, and actually taking the data sets from Hugging Face or wherever that are typically stored in a file format called Parquet, spelled Parquet, That is a a binary compressed format to lower energy and memory storage overhead, and then converting that into the actual, typically like a CSV file, so think of it like Excel, to be able to edit it and make sure that they're going line by line over this data set versus the easier answer of, oh, well, other people publish this data set, so we're just going to take it and say it's all good. So here, right, we end up having additional multimodal evaluations. So the New England Journal of Medicine Image Challenge, closed-ended visual question answering, closed-open visual question answering. And really we're seeing, again, the point of this isn't about, is this going to replace a clinician? This is a tool. This is a tool, and I think it's with good due diligence that the authors in this paper highlight regularly, abundantly, talking about how this is great and they're really excited about the possibilities here, but in no stretch does this replace or even augment a clinician. This is about the right use cases and developing standards together in partnership across that, because we see with these long EHR and video tasks, so electronic health records and video tasks with Med Gemini M 1.5, which as far as I can tell with all of these Med Gemini models, they are the base Gemini model that is fine-tuned on these different data sets. So like Gemini small being like the Gemini Nano, so that's a smaller model, versus Gemini Medium, which I think is their Pro model, and then the Gemini Large, my understanding being that it's their Ultra model. If I got that wrong, apologies on that, but they're taking their different baseline models and then fine-tuning them on medical information. The fact that they're tuning it and able to assess it on videos is just absolutely bananas, because now you can just be able to actually have it go through and help clinicians, help learners, help anybody be able to take a dense topic that's seen in a video where to the uninitiated, you don't even know where to look initially, and breaking that down, summarizing it, helping to understand all of that information in a personalizable format. That by itself is huge and super exciting to be able to see that capability being highlighted. And so, and they speak to that point exactly here, the procedural video in clinical practice and education. And is it that it's going to end up getting it 100% correct every time? Well, of course not. Also, no person will end up getting every single thing at a time. It's about now working together to identify, okay, if this thing can take videos and summarize them and really draw out all concise data points from it, how can we use this to help people learn? How can we use this to give that initial feedback? And again, understanding that at the end of the day, an AI, what it produces is just one data point. In navigational terms, it is an azimuth of, hey, if you're using a compass, you would end up aligning your compass, looking at the point where you're looking for, saying, hey, I think it's about 117 degrees, so I want to go about here as you're holding the compass in your hand, aligning it to where you're actually looking, and then going that way. Or a back azimuth of, or we'd call it a panic azimuth of, hey, I know that if I completely get lost, I go 180 degrees back, and that will get me back to the starting point. Definitely something where you should be depending completely on it to make your clinical decisions. And really, again, with any AI, it's not about taking this information and saying, oh, well, this is the prescriptive right answer for this. New information is being put out all the time. It's about helping to streamline that process of, because, not every single paper is going to be as good as the other. And even the diagnostic codes, the ICD, what are we on, 10, 11? I think 11 at this point, that actually drive the relative value units and the coding, that really box the diagnoses for the purposes of aligning resources to care, those are constantly changing. And it's a difficult task, to say the least, for clinicians to keep apprised of that information. So, by and large, it's the ability to take all that information and consolidate it. So, like from clinical practice guidelines, from those codes, and being able to point to where the new data points are coming in that are aligned with getting the best possible care. And what does that care look like? Well, that's going to depend on that individual clinician to ultimately make that choice. And so, with this, though, with the data sets, one thing to highlight is because it talks about, right, these different like Med QA. So, going up here, boop. And, right, so this is the actual paper here. But the reality is with a lot of these, so this being the Compass Hugging Face page, where we're just consolidating a number of these different data sets, all publicly available because they were made publicly available, is that there may be different versions of it. So this is the massive multidiscipline multimodal understanding of reasoning benchmark for expert AGI. Bleh. That is quite a mouthful. But that is one for multimodal training. Right, so when we think of a VQ or visual question answering, that is what that entails. Versus, let's see, the visual genome. So we end up having different, well, from left to right here, the image or image description, the URL, width, height, and all these different attributes. But noting that again, not every data set is going to be a little bit different. And for Med QA. It's like Med QA, for example. There are a number of different versions of Med QA here. And so it is important when considering assessing, okay, what is the validity of a particular data set? If it is a popular data set, more often than not, there's going to be multiple versions of it. And so ensuring that you are being thoughtful, mindful of ensuring you're looking at, and for anyone who's publishing, to put the specific data set that is used in the specific version versus just, oh, we use this. Now, granted, if they're saying, hey, we took it and we've modified it, we haven't pushed that out yet, as my understanding being that what the Gemini team did here, so I think they had, what was it, R? Yeah, so they produced additional new data sets, so right, from MedQA, and then they made a new data set, MedQA-R. And so collecting expert demonstrations, including how experts make informed use of knowledge retrieval tools such as web search, is both time consuming and difficult to scale. Agree. To overcome this, they generated two novel data sets with self-training as described below. MedQA-R reasoning, which extends MedQA with synthetically generated reasoning explanations or chain of thoughts, and MedQA-RS, reasoning and search. So again, they acknowledge ad nauseum that MedQA is a benchmark. It's a benchmark that's known in the community, but it is not the end-all be-all. And so because of that, they augmented, they amplified, whatever the A word you want to use to that, but they acknowledge it and made improvements on it. To my knowledge, they have not released that particular data set, that novel one they made, but it's encouraging to see them highlight and have a sense of what the pulse is for the industry, for research, and then that they also point out that, hey, we acknowledge that we need this needs improvement, and we're going to talk about how we improved it. And of course, the real test, though, with any of these models, because in the lab, it's always typically very, what's the word look for? Pristine, very much of, and even we see with contamination of data sets by data sets, if you train a model on a data set like the MedQA or really anything, and then part of the evaluation, like the Open LLM leaderboard or the Open Medical LLM leaderboard, is testing from that data set, well, there is a potential for contamination of a model does well because it has effectively seen the answers before. Now, again, this isn't, I haven't seen under the hood for any of these particular models, and so can't say for certain with that, but it is important enough that a number of people have published about how these different data sets have, or how these benchmarks have, in some ways, shown limited, or their value is limited because of the fact that there is such a preponderance for contamination, and because people see, oh, well, if I'm number one on the leaderboard, that must mean I'm better, which means I'm worth investing in, or winning a contest, or getting an award, or whatever, right? So the benchmarks are a data point, a series of data points, but again, as this paper goes on with 56 pages, which like uh, it is important to be mindful that there's more than just that initial benchmark. It's more than just the leaderboard. The leaderboard is flashy and it's something everybody can look for. So it is a good thing to reference, just of saying, okay, what is happening there? But the reality again is that that leaderboard, particularly the open LLM leaderboard, medical one, it's too early to tell, but the open LLM leaderboard, if you look today versus next week, the numbers will be different. It is just constantly fluctuating. And so the point there should, it's more about, okay, there's a certain level of success you want to see, a certain level of quality you want to see for a model. Do you have to be number one? I would argue no. It's more about, hey, have you met a threshold? Even in medical education, a lot of schools have gone to pass fail. So as long as you are meeting a baseline threshold of 70%, consider it a pass. So I think that is more, not for all use cases, right? Not for everything, but it's more that I think that's a better mindset to take with a lot of these models, because again, and with that understanding that that's one benchmark, and then you have to then take that, fine tune slash put your own guardrails, like NVIDIA's Nemo Container Toolkit, pretty good. Also, the Morpheus, pretty good in terms of really being able to see that, or Meta's Guard Llama, Purple Llama, both good in terms of red team, blue team, and ensuring that we're having safe, responsible, reliable AI. So hopefully this was helpful, and it's really going to be interesting to see how that ability to take video and crunch that down is going to be used, right? Because the fact of what is video, but really text, image, audio all at once, and the fact that it can use that. I mean, think about how that can be used to help teach, how that can be used to help deliver and synthesize, say, like an after visit summary, not the actual clinical diagnostics. Again, like for those who don't want to go through that, but to have a way of a patient could ask, hey, I want to see, like, I want to see a video of what this is, this procedure, this thing, or for a clinician who wants to be able to help their patient understand about a video that they find helpful but is in a different language. And so to be able to have that model take that video and convert it to a different language for that patient so they can ultimately feel empowered, safe, and understanding. That shared decision-making model can actually be delivered. So I think that is really great, but again, it's a one tool and still very nascent. Very nascent. But considering that a lot of technology is still, some of the current tools are way behind this, but I think it's just really exciting to be able to see it, and I'm looking forward to see where the uses for this are going forward. To be able to take that information, not copywritten, right? You want to avoid all that because that's bad. But to take synthetically generated information, to be able to take clinical expertise, and then help that for shared decision making, to compress information into actionable decisions, because that's at its core, that's really what intelligence, artificial otherwise, is. So, you have a good rest of your Wednesday, and I'll catch you in the next one.